Today we're going to present the all-new KR KUKA Robot Fortec Ultra robot family, which is released just a few weeks ago for sale. Now, the new Fortec Ultra robots is a new complete family of robots in the heavy payload portfolio. And it is really a compact and powerful robot. But not only that, we have focused on bringing down not only the cost of the robot itself, but also the cost of ownership, and make sure that this is as sustainable throughout its complete lifetime as it possibly can be with today's technology. Now, a little bit about the background about this robot. Well, one of the reasons we developed it is that there's quite fast changing requirements in the industry or business of robotics today. Typically, parts and tools get larger, bigger, and heavier. That means that we need more powerful robots, which also can handle quite big inertia as tools and loads get bigger and bigger. And that is relevant for all type of industry, not only the automotive industry, but that could be the housing industry, the aerospace industry, the foundry industry. And we've been in this business for a pretty long time now with the heavy robots like this. And actually, this new family of Fortec Ultra closes a gap we had in our product portfolio between the older KR Fortecs and our biggest Titan series. And if you look at what we call the heavy portfolio, which is between 360 up to 1300 kilo payload, we now have up to 40 variants of this in this field. So it's a quite extensive program of heavy-duty robots we can present to you. Now, if we are looking more closely into the new family, the KR Fortec, we can see that there is actually 5 variants of them, ranging from 480 kilo payload with a reach of up to 3,400 millimeters, and going all the way up to the KR 800, which takes it the 800 kilo payload, has a reach of 2,800. There's also a long reach variant for the 480 kilo payload, which actually reaches up to 3,700 millimeters. Now, there's also special variants available of 2 of these, which are called high inertia. High inertia means that we can handle really large tools and payloads, which have really high inertia in themselves. This is pretty common in both the battery production, in the foundry production, but also more and more in the construction and building developments or business. Now, at the end of this year and the beginning of next, there will be some more variants of this. The foundry variants, which are specifically developed for the foundry and industry, and also the machine tooling variants, which then are specially developed to have extra stiffness and so on. This is typically when you do turning or friction welding and so on. Now, thanks to its pretty unique design, with this double link design, this robot is really a very powerful and very stiff robot, which has absolutely the best payload weight ratio on the market. It also allows us to handle a very high load payload with a very light robot in itself. And of course, thanks to stiffness, we're also able to handle quite large payloads, which makes us pretty unique in the market today. Now, we have also done some benchmarking with these robots, and we can actually see that we have been able to reduce the cycle times of the robots and increase the acceleration. That means that we can reach quite fast, short cycle times. That means that we actually, if we compare this new 640 kilo Fortec robot with the older generation of the Fortec robots, which could handle up only 600 kilos, the new one is actually 10% faster in the same cycle. Now, not only the cost of the robot is important, but also the cost of ownership. And this is where we put in a lot of effort in the robots. So we have actually developed a robot which is the most reliable robot in this payload class. And what do we mean by this? Well, the technical availability of the robot is actually, as you see, 99.998%. The mean time between failures is up to 400,000 hours. The maintenance time has been dramatically reduced. It's now 5.7 hours. And the mean time to repair the robot is actually under 1 hour, of course, depending on what type of repair you need to do. How do we then reach this? And well, there are a few tricks up our sleeve to do this. Well, we have selected specifically components with very low maintenance requirements. That means that the internal cable set within the robot is designed to last the complete lifetime of the robot. That means that there is no change of the internal cabling in the robot. The inline wrist of the robot is without belts or carbon shafts. And we have a hydropneumatic counterbalancing systems. That means that there is no springs to maintain, no necessary inspection by external parties. Now, we have also performed some changes to the components. So there's a new routing of the energy supply system, and we have upgraded the cable protection of it. There is a completely new sealing technology for the gearboxes with a new oil type that should prevent all leakage from it. And all this means that we have brought down the maintenance requirements with only 3 simple actions to perform: a visual inspection, a greasing of the counterbalance system and the cable set, and the oil change, which is only required once every 20,000 hours. And there's just one type of oil, and there's no grease needed to do that, no warming of the oil needed to do it either. So this is really as close to maintenance-free as you can get from a robot today. And we've also worked pretty hard on reducing the weight of the robot. And thanks to its design, we've been able to do that quite a lot. And we'll look a little bit deeper into that. But of course, a reduced mass means a lower energy consumption. There are also quite few spare parts available. The robot is not built up of blocks of components, which are quite few. And it's very compact for its size of payload. And actually, when we compare it using the IDA protocol, which is a standard for measuring energy consumption of a robot of a standardized cycle, we can see that our new robot here, the Fortec Ultra, actually saves 8% compared to our old robots, the Fortec 1 in the same cycle. So if we look at all this together, we can see that we have improved quite a lot from our older robots. The max payload of that series has gone up from 600 to 800 kilos. The mean time between failures has dramatically improved. The mean time to maintain has gone down quite significantly, as you see, almost half the time. The mean time to repair has gone down somewhat, and the availability of the robot has dramatically improved. But actually, when we look and discuss about cost of ownership, we should remember that over the complete cycle, the robot uses electricity. And in this graph, we can see what's happened to the price of electricity in Sweden over the past few years. And I think that looks pretty much the same in all countries, more or less. You all know that the price of electricity has gone up dramatically, and the fact is that it will probably not drop down to the levels we were used to in any foreseeable future. And in any robot cell, the cost split up over the total lifetime. The energy is, in many cases, actually the largest part of the cost of the lifetime of the robots. It could be anywhere between 30 and 40% of the total cost of ownership over the complete lifetime, depending on the application, of course, you run. That means that it's actually really interesting to bring down the energy consumption. And one way of doing this is quite obvious in this graph here. Here we compare our robots with the older version, where we see our Fortec 1, the older one, which had a maximum payload of 2.6, maximum payload of 600 kilo and weighed 2.6 tons. And here we can compare it with the new Fortec Ultra, which we are talking about today, which has a payload of up to 800 kilo, which is actually slightly lighter than the older one, even though the payload has gone up. And if we compare it with its bigger brother, the KR Titan, which has a payload of up to 1,000 or 1,300 kilos, you see that the weight there actually goes up to 4.5 tons, which is a significant change. And when we look at our main competitors in this market, we can see that we were pretty much on par with our competitors in the weight class of up to 500 kilos. But when we look in the weight class up to 800 kilos, we can see that our competitors are more than 2 tons heavier in the same weight class as the Fortec Ultra for 800 kilos. That means that we could actually say that our competitors in the 800 kilo class, they are actually moving the extra weight of a full car. And of course, that affects a lot of your costs, not only the energy consumption, but the need for a more sturdy floor foundation. And as the parts and the robots themselves are heavier, the spare part and the service costs are likely quite higher as well. So it has a huge impact on your cost of ownership is actually the weight of the robot itself. And again, we are more than 2 tons lighter than our competitors in this field. But also cost of ownership is also sustainability. And the fact is that thanks to the very modular design of our robots, we can rebuild the robots, reconfigure the robots in the field. We can actually give the robot a new life in the field, which has a very big impact on your cost of ownership over time. So we can actually upgrade or downgrade the robots in the field to a higher payload or to do the high inertia variants. And of course, the spare parts availability is more than 10 years after the end of the product cycle. So we guarantee the availability of the spare parts more than 10 years after that the product has been cancelled. So let's bring this together. So what we call that the Fortec Ultra, we call it from a sustainability point of view, a green robot. Thanks to its very low energy consumption, considering the payload class it is in. This comes from the reduced mass of the robot, that we are utilizing the very latest drive and controller and software technology to make the control of the movements as energy efficient as possible. And it's a reusable robot. It has a second life ability. We can actually reconfigure the robot in the field at your site. And we have a very high mean time between failures and a very high robot lifetime. And if you want to go further in your energy saving, it is DC ready. That means that we can actually, instead of supplying it with AC voltage, we can set it to a DC voltage network and then use the regenerative effect of the drives when we are braking the robot. Instead of burning it away as heat, we can generate electricity and feed it back to the net. So we are nearing the end of this very short presentation of the Fortec Ultra. I think you understand that I could happily talk about it all day. Now, if you want more information about this robot, it is available on the website my.kuka.com, which requires a registration, which is of course free charge. There you can find all the specifications and the technical data of that robot. You will find it under the field. Once you get in there on the marketplace, and then you go into robot, heavy duty class, and the Fortec series, and then you can find the Fortec series. There you find not only the presentations and the specifications, the data sheets of the robot, but you can also find technical information such as step files, CAD files of the robot. And if you want to, or thinking about using a robot in this class, you could actually try the validity of your specific load directly on our website load.kuka.com, where you can go in and enter your payload data with the offset from the flange and get a report whether this robot is a suitable robot for your specific load. This is available online right now. The robot is orderable right now, and the first deliveries will start in April. Now, this webinar will also be available on our YouTube channel, KUKA Nordic. And there are a lot of more webinars on our further recent topics here, and some instructional videos as well. So please have a look at this website. And with that, I do thank you for your attention and hope for any questions. And let's see if there are any questions in the chat field. Now, Martin is asking if we will supply energy consumptions examples of robot application, including attached equipment and loads. That has been a discussion internally, actually, but we find that the number of possible energy applications and load applications are endless, basically. So what we've done instead is that we have built in the possibility in our simulation tool, KUKA Sim, to actually run a simulation where you input your load data. You can run a complete cycle, and KUKA Sim will tell you exactly what the energy consumption for that application is. So instead of providing generic examples, we give you the possibility to do an exact simulation in terms of energy consumption for that exact application. And that also, of course, gives you the possibility to do slightly changes to the layout or to the robot program and see how the energy consumption changes with those changes. So we hope you think, because we think that that is a better way to provide energy data for that robot. I hope you agree. Any more questions? My colleague Peter asks if KUKA Sim 4.1 can do energy consumption today. Yes, it can, but that actually requires the use of Office Lite. In a few months, we will release the update of KUKA Sim, which will be called 4.3, and then that will not require the Office Lite, but KUKA Sim can do it directly without Office Lite.
Industrial intelligence.